we're going to finish out the quadratic formula today with questions that aren't quite as pretty as the first section. So just a reminder, the quadratic formula is there for you. In case you haven't written it down, make sure that it's there. Make sure that you know it. It will not be given to you on test or quiz. So again, another reminder, make sure that your equation's equal to 0 and that it is in fact a quadratic before you try to use the quadratic formula. So taking a look at number 1, again, we're going to do the same process that we did in the lesson before. I'm going to start by saying A is 2, B is -6, and C is 3. So the formula starts x equals negative b, which is the -6, plus or minus the square root of. Remember I said anytime that b value is negative and you square it in the calculator, make sure you throw parentheses around it. -6 squared is 36, minus 4 times 2 times 3, all over 2 times 2. So now I've got +6, the negative turns positive, plus or minus the square root of. And again, we're focused right on the inside there. That's going to be 36 minus 24. 36 minus 24. Actually, I made this little, whoa, I don't know what just happened there. I made this a little longer than I needed to. That's 12. On the bottom, 2 times 2 is 4. So just a very quick aside for you, if you did the factor ladders that we did in the beginning part of this chapter, the square root of 12. Square root of 12, if you either put it into the calculator or do the factor ladder, you get 2 root 3. So I'm going to replace the square root of 12 with 2 root 3 in the next step. I get x equals 6 plus or minus, and now I'm going to put that 2 root 3 next, all over 4. Now, in the lesson before this, that radical turned out to be pretty. It was a number we could handle. And so that's when I made 2 statements, red and green for Christmas colors. But today, I don't know what the square or 2 root 3 is. So all we're going to do is uncommon denominator and simplify. Uncommon denominator means I'm going to take the denominator and I'm going to give it to both terms on top. So I'm going to make this x equals 6 over 4. 4 goes to the 6. Plus or minus 2 root 3 over 4. And the reason I do that is because it makes reducing easier. 6 over 4 is 3/2, and 2 over 4 is 1/2. I don't need to write the 1, but I will write the 2 on the bottom. My final answer is 3/2 plus or minus the square root of 3 over 2. Not nearly as pretty as the answers were on day 1. Same process, different looking answers. All right, taking a look at number 2, I have to start by subtracting 4 from both sides. Minus 4 on both sides. And when I do on that left-hand side, I'm going to make it 2x squared minus 8x minus 4 equals 0. So my a value is 2, my b value is -8, and my c value is -4. X equals negative b, which is -8, plus or minus the square root of b squared. -8 squared is a positive 64. Minus 4 times a, which is 2, and c, which is -4, all over 2 times a, which is 2. So the -8 turns positive, and under that radical, I've got 64 minus 32. That's 32, all over 4. I'm going to deal with that square root of 32 off to the side like I did before. The square root of 32 can be broken into a 4 root 2. Use the calculator or factor ladder if you need to. And so what we really have here is x equals 8 plus or minus, and again, I'll replace it with the 4 root 2 all over 4, and then I'm going to uncommon denominator. That means x equals 8 over 4 plus or minus 4 root 2 over 4. When I reduce, I get x equals 2 plus or minus root 2, because the 4 over 4 becomes a 1, and we're just left with the square root of 2. I want to point out, whatever that number is under the radical, that never gets reduced. So even though I reduce the 4 and the 4 out front and the 4 on the bottom, I don't reduce that square root of 2, I just leave it like that. All right, number 3. Number 3 looks considerably different than the others because a value is missing. My A value is 3, but my B value is 0. And that's okay. It's a little weird, but there's nothing wrong with that. I'm going to start with x equals negative b is negative 0, plus or minus the square root of b squared is 0 squared, which is 0, minus 4 times 3 times negative 5, all over 2 times 3. So I get 0 plus or minus the square root of 0 minus 4 times 3 times 5 is 12 times 5 is 60, all over 6. Off to the side, I'm going to do that square root of 60. That's 2 root 15. And of course, the denominator here is 6. So I want you to be really careful. What we really have at this point is 0 plus or minus. The 0 there is kind of unnecessary. So I'm going to get rid of that. We have plus or minus 2 root 15 over 6, and that reduces. We really have a plus or minus root 15 over 3. Pause the video to do the you try it. You don't need to write the answer as 2 separate quantities like I did here. That's up to you. But at this point, you're more than welcome to write it as a plus or minus instead of 2 separate ones. Take a second, make sure this chart is filled in. So there are 3 situations going on. The discriminant is what is underneath the radical in the quadratic formula, and it allows us to determine how many and what type of solutions we have. So I want to start with the first option. If that discriminant is positive, you have 2 real solutions, and that's what we've been doing this entire time. We got 2 real answers. The second option is when the discriminant is 0. Now that happened on the very first question we did on the quadratics on day 1 of section 7, where we got a multiplicity. I don't know if you remember or not, but x was negative 3 with a multiplicity of 2. That's rare, but it can certainly happen. The last option is when it's negative. If that discriminant is negative, which we will not have until section 8, you get 2 complex solutions because they're imaginary. Again, not something you specifically have discussed before, but it certainly can happen. So you're going to notice the directions here don't say solve. They're going to say find the number of solutions. They may say use the discriminant, but that's kind of implied by number of solutions. So we're going to start it the same way. I'm going to bring that 49 over to make it a negative 49. Set it equal to 0 first. My A value is negative 1. My B value is 14. And my C value is negative 49. But now all I have to do is the discriminant part, the b squared minus 4ac. That's all I have to do, and I just have to determine whether it's positive, negative, or 0. So if I put 14 squared in for b, I get 196 minus 4 times negative 1 times negative 49. You can type that whole line into the calculator if you want. I'm not really picky about what work you show, but at this point you should have a 196 minus 196, which is 0. When the discriminant is 0, you have 1 real solution. So your answer isn't what the solution is, it's what kind and how many you'll have. That's what the discriminant tells you. Number 2 is not set equal to 0 either, so I'm going to start by subtracting the 4. Remember, in standard form it goes last. My A value is 2, my B value is negative 1, and my C value is negative 4. So all I'm doing is b squared minus 4ac. b squared is negative 1 squared. Make sure you use the calculator in parentheses on that. Minus 4 times 2 times negative 4. I end up with 1 plus 32, which is 33. That's a positive 33. When your discriminant is positive, you're going to have two real solutions. Number 3, not equal to 0 either. So I'm going to start by adding 50. 2x squared plus 10x plus 50 equals 0. My a value is 2, my b value is 10, and my c value is 50. So for b squared minus 4ac, b squared, 10 squared is 100, minus 4 times 2 times 50 means 100 minus 400, which is negative 300. So this is going to be two complex solutions. I didn't even spell complex right. Sorry about that. Pause the video to do the you try. I do want to take a moment to point out in that last, or in number 5, if it says too complex, that's the same as no reals. So either of them are technically correct. No real solutions means they are two complex solutions. As a wrap up, today we solved quadratics using the quadratic formula and wrote the answer in simplified radical form.